What is at the edge of the universe? For many centuries, humans have wondered exactly what lies at the edge of the universe but have got no clue. However, barely months after the new James Webb Space Telescope became operational, it has discovered something huge and tantalizing at the edge of the universe that threatens to turn physics upside down. What has the new Space Telescope found at the edge of the universe? Why are scientists so excited about it? Join us as we dive into how the JWST just discovered something massive hiding on the edge of the observable universe. Can the JWST see the edge of the universe? When you witness the development and launch of a $10 billion space telescope, it is not out of place to wonder if it can see that far. First things first, the JWST is 100 times more powerful than the iconic Hubble Space Telescope. It can capture very faint infrared light from the very first galaxies, which are found at the very edge of the universe. It will also be able to study planets around other stars in our own galaxy, examining their atmospheres for telltale signs of life. In fact, the JWST has the nickname First Light Machine, derived from the fact that it will capture images of stars formed just 250 million years after the Big Bang. The JWST comes with sophisticated equipment to be able to see that far in time and distance. It uses a 21-foot mirror made from ultra-lightweight beryllium that is divided into 18 hexagonal segments and then given a gold coating. The JWST's mirror is exposed at its location in space, so NASA is protecting it with 5 parasol-like sheets of aluminium-coated plastic. They are as thick as notebook paper and as big as a tennis court, and they block out light and heat from the sun, moon, and Earth. And it has a total of 4 solar-powered cameras and sensors that collect data. But the question is, when scientists train the telescope at the edge of the universe, what will it see? There is the universe, and then there is the observable universe. In simple terms, everything you can see, assuming your eyes could detect all types of radiations around you, is known as the observable universe. There is a certain limit to the observable universe because in visible light, the farthest we can see comes from the cosmic microwave background, which was about 13.8 billion years ago. At that time, the universe was opaque. You can imagine a thick fog. There are scientists that claim some neutrinos and gravitational waves that surround us originate from even farther than that. However, that claim cannot be substantiated yet simply because we don't have the technology to do so. However, if you prefer a more technical explanation, cosmologists say that the observable universe is just the nearby part of a greater entity known as the universe, where the same physics applies. One of the things scientists have discovered at the very edge of the universe is a galaxy named Abell 2744Y1. This galaxy is special for many reasons. Abell 2744Y1 is so far away that light from it gets to us after 13 billion years of traveling. Remember, the universe is estimated to be 13.8 billion years old. One thing about Abell 2744Y1 is that we are seeing it as it was when it was only 650 million years old. This is true of all distant objects in space because the light from them has taken so long to reach us here on Earth. Abell 2744Y1 was discovered using a total of 3 telescopes: Spitzer, Chandra, and Hubble. But just how did 3 telescopes come together to discover a single item? Well, the Hubble captures images in visible and near-infrared light, while the Spitzer has the advantage of using the infrared portion of the electromagnetic spectrum. Scientists use Chandra to collect additional data using X-ray wavelengths. By combining data from these 3 space telescopes, astronomers are able to see galaxies up to 100 times more distant than any of the observatories could have done individually. The astronomers attached to the Instituto de Astrofísica de Canarias (IAC) and La Laguna University in Spain started with the Hubble, which detects the galaxy in question. This is then followed by the Spitzer, whose instruments are used to calculate the distance of the object where it's located. The telescope also helps to determine how many stars are in the galaxy. The scientists also used a method known as gravitational lensing when they photographed Abell 2744Y1. The underlying principle is similar to how a magnifying glass bends sunlight, because images from distant galaxies are put into focus by galaxies closer to Earth. This natural telescope to view the most distant objects in the universe was first predicted by Albert Einstein in his general theory of relativity. So how large is this galaxy? Astronomers say Able 2744y1 is quite small in size. It is about 50 times smaller than our own Milky Way galaxy, or about 2,300 light-years in width. However, what this galaxy lacks in size, it makes up in the rate of star production. It generates stars at a rate 10 times faster than the Milky Way, but that is typical of galaxies in the young universe. The Able 2744y1 galaxy has a redshift of 8. Redshift is a way of measuring the degree to which an object's light has been shifted to redder wavelengths due to the expansion of the universe. In comparison, the farthest confirmed galaxy before the discovery of Able 2744y1 has a redshift of more than 7. From the most distant galaxy ever captured, we move to another distant object, this time a supernova. What is the most distant supernova ever spotted by astronomers? That title goes to DES 16C2NM. If you are wondering what is up with the name, it is because the supernova was first spotted by the Dark Energy Survey, which is a research work that seeks to better understand the mysterious force thought to be responsible for how the universe's expansion is accelerating. Supernovas are some of the biggest explosions we can ever have. Picture an atomic bomb, but with infinitely more bang. They are like the last valiant effort made by stars before they die. The stars here are at least 5 times bigger than our own sun. Here is how stars work so that we understand how they die. Massive stars basically burn humongous amounts of nuclear fuel at their cores. This leads to the release of tons of energy, and as a result, the center gets very, very hot. This heat generates pressure, and the pressure created by a star's nuclear burning also keeps that star from collapsing. When you see a star in the sky, it's because there's a balance between two opposite forces. On the one side, the star's gravity tries to squeeze the star into the smallest, tightest ball possible. On the other side, the nuclear fuel burning in the star's core produces a strong outward counterpressure. This outward push resists the inward squeeze of gravity. But when the fuel runs out, the star starts to change its behavior. It begins to cool off, causing a drop in pressure. This goes on until gravity eventually wins and the star collapses in a spectacular fashion. This is a brisk affair as the collapse occurs in a short period of time. It would be like the Earth collapsing in just 15 seconds. This collapse creates shockwaves that cause the outer portion of the star to explode. You can also have a supernova when two stars collide. Supernovas are not that common. You could have 2 or 3 in a century, so it is always special when a supernova occurs. DES 16C2NM was detected in 2016, and scientists confirmed a supernova like that is extremely rare. It is like the very extreme version of what you call normal supernovas. The discovery was made by a team of international astronomers, and they say the explosion took place about 10.5 billion years ago. This means the light from the explosion has been traveling to us for more than 3/4 of the existence of the universe itself. What is even more mind-boggling is that the location of the supernova is even more than that, thanks to the expansion of the universe. The team also enlisted the help of 3 powerful telescopes: the Very Large Telescope, Magellan, and the Keck Observatory. It involved more than 400 scientists from all over the world and took 5 years with 525 nights of observation. While the scientists ran into many troubles to locate the supernova, the effort will pay off in many ways. The extreme distance of DES 16C2NM gives the scientific community a totally new insight into the nature of superluminous supernovas, or SLSN. Scientists can determine the amount of metals produced in the explosion by studying the ultraviolet light from the SLSN. It can also reveal the temperature at which the explosion occurs. These 2 things here are key to the understanding of what causes and drives these massive cosmic explosions. However, it may not be long before another, more distant supernova is found because scientists are out looking for them, spurred on by the extraordinary discovery of DES 16C2NM. How about a whole galaxy discovered through luck? Sometimes the universe turns up things by surprise, and one such unexpected gift is Bed-in-1. The universe is vast, but it contains so many objects that it can't help stacking them behind one another. You'll find nebulae, star clusters, and galaxies all one behind another. This was exactly the case when the Hubble was used to photograph a globular star cluster named NGC 6752. This cluster is located 13,000 light-years away from us in the Milky Way galaxy. The scientists were shocked and also excited to find a totally unknown galaxy behind the cluster of stars. The galaxy is a spheroidal dwarf and is located about 30 million light-years away, meaning it is about 2,300 times farther than the cluster in front of it. This means the new dwarf galaxy is relatively close. Spheroidal dwarfs are known for their small size, low luminosity, lack of dust, and very old collection of stars. This new galaxy was nicknamed Bedin 1 after one of the researchers that found it. It is called a dwarf because of its size. It is about 3,000 light-years at its greatest width, meaning it is barely 1/30th of our own Milky Way. It is about 1,000 times dimmer as well. Bedin 1 is about 13 billion years old and very isolated. It is about 2 million light-years from its closest large galaxy, the NGC 6744. This makes it more or less a living fossil from the early days of the universe. Let's hear what you think of the vast universe in the comments section below.